welcome to our workshop series Kubernetes from Zero to Hero. Over the next 6 weeks, I will walk you through the basics of microservices and Docker, Kubernetes basics, Kubernetes security, the concepts of operators, and Istio mesh networking. See you every Wednesday afternoon, 2 p.m. Central European Time. Enjoy. So let's talk about the labs. So we had the session yesterday, the preparation session, where we had 3 people dialing in. So I guess everybody's more or less okay with the lab environment. So you have downloaded the VM, you start it up, you get your what I call the personal training environment, the PTE, within the VM. So it's completely self-contained. So you can do all the labs, basically the ones that we've already did, the one of today, and the other ones, you can do them in July or in August if you like. Just start up the VM. You have this training environment which contains all the different labs and with the recipes, with the walkthroughs, and you have everything pre-installed. That's why I did it in a VM, because it would be too complicated to handle everybody installing that local on a machine. So if just some remarks, if you get software updated, just click remind me later. We don't need that. I developed the whole thing for Switzerland, as you can see. So you have to add your own keyboard layout. If ever it's on the right side, right upper side, you can change that. Then you start the terminal and you type /welcome.sh, which will start Docker and some additional stuff. Minikube, it prepares the networking layer, starts the personal training environment, and starts Kubernetes Dashboard. So the most important part is to start Minikube. If Minikube is not coming up, please go back to the snapshot. We have a vanilla snapshot of the image and try to redo it again. Okay. At a certain point in the setup, you have to enter your name. You can enter your name or just anything. It doesn't matter. Something that you can identify with. Because the results will get forwarded to my Instructor Dashboard, and I try to follow along a little bit to see if there are people who are not able to follow, so I can ping them on Slack. But basically, there's nothing recorded except that, and I scratch it after the training. Good. Some troubleshooting. I guess everything's okay because we didn't have more messages. But just in case if the startup script doesn't work or you're completely stuck, you can launch the reset environment.sh, which will scratch completely the Minikube installation, but it will have to re-download all the images for Minikube and all the rest, and that takes at least 20 to 30 minutes depending on the internet connection. So it's a bit slow. Well, slow. It has to download a lot of stuff, so plan ahead if you have to do it. If you close by accident the PT, the personal training environment web page, I didn't bookmark that. Just run Minikube service student UI, that will open the student UI service in the browser directly. We had seen some Windows 10 problems because we're using what we call nested virtualization to have Minikube run in a VM. So we have a VM running in a VM, so that's called nested virtualization. And if you have Hyper-V running, that can wreak havoc with that. So you have the command bcedit set hypervisor launch type off and reboot, and then it should work, and afterwards you can turn it back on with auto. A lot of people last week have been asking if they can do it on their machine. If you're technically savvy and have Docker installed and Git and Minikube, well, Git, the command line Git, you can just try to clone the repository directly. And I've made a new directory in there called standalone, so /training/standalone, with another welcome script that should hopefully start the elements that you need, the basic elements that you need for the different labs. Obviously, it's untested. I cannot test that on all different machines. For example, I don't have a Windows PC, so I cannot test it. So it's up to you to see if it works. And for today's and next week's lab and the ones to come, there will be some stuff missing because in the VM I've pre-installed some security tools and some tooling that will help you along the line. In the training environment, you will have the links to the Git repositories or the web pages of those tools. where they explain how to install it. So you can do it. You can do it on a local Minikube. You should even be able to do that on an IBM Kubernetes, Cloud Kubernetes instance, or on Amazon or Azure or whatever. But again, it's untested. Good. Last week we rapidly talked about K9s, which is basically the Norton commander for those old enough to know that, to remember that. It's the Swiss Army knife for Kubernetes. So it's pre-installed in the training environment. You can install it fairly simply on your Mac or on your PC or whatever. It gives you the possibility to easily navigate the different objects that are running, to edit them, to see the logs, to kill a pod, for example. And if you start it up, you can see everything should be in running state. You should have, so it should be blue. You should have 1/1 for all the components. As long as you have red stuff or container creating, it's still initializing, so you won't be able to start with it. So that's an easy way to just rapidly check if your system is doing okay. And if you start it up and you don't see all of that, just hit 0, the key 0, to see all the namespaces, so all the elements that you have in your cluster. Good. So once this welcome is completed, it should open the Kubernetes dashboard and the collector, which is the personal training environment, and then you're good to go. So you will be selecting in the dropdown on the courses tab, you will select the Kubernetes Security Labs. Click on begin course, and you will go to the classwork tab, and then you have all the different tasks. So you have a drop down with all the tasks. You can jump between them, but try to do them in order because you will miss some stuff. So once you've completed one of the steps, you hit complete, then press mark to complete it, and it automatically goes to the next step. Okay, so next tab, you can see where you stand. So you get all the different tasks that you have in your course, and you see how many you have already completed. If you do them out of order, it won't check something like 11 here, for example. It will just show you how many you have done. It's not that intelligent. And I have my Instructor Dashboard. Let's leave it at that. Okay. So what happened so far? What have we seen last week? Let me just get Slack for a second and see if there's questions. Okay. No problem. Michael. Okay. So yeah, that was my bad. Didn't deserve a Kubernetes trainer. What is the Kubernetes trainer doing in here? You're probably 10 times better than I am. Oh, good. Okay. So connection to the server. Yeah. That's normal. You have to wait until everything comes up. So so that can take some time because it has to download all the different images. So that might be normal. I'd have to check afterwards. Good. Okay. So what happened so far? What have we seen? So we 2 weeks ago we talked about microservices, containers, why everybody loves containers, why it's a cool thing to encapsulate your applications, to have them just run one small part of your applications per microservice, then the containers, and in the end Docker or Cryo or whatever to execute the whole thing with all the problems that go with it and so on and so forth. Then last week we talked about Kubernetes. Those who were in remember the Kubernetes architecture, and you've seen that in the quiz as well. So we have the master nodes. Usually it's more than just one for high availability. Usually you have 3, 5, or more. With the APIs, kube control or others to interact with your cluster, to create objects, to delete objects, to modify, and so on and so forth. And the API server will store whatever you throw at him in this distributed storage called etcd, which is a high available distributed storage, very resilient. Then we have the scheduler and controller manager that are monitoring what gets in, what comes out, and then the kubelets on the worker nodes will monitor that and say, okay, hey, the scheduler said that I have to run a new pod, for example, a new deployment. So the kubelet will start the containers on the, well, I've Docker in here, but on the container engine that runs on your worker nodes. And on the worker nodes, obviously we have the kube proxies that are responsible for routing the external ingress traffic that's coming to your cluster. We also had a question, and I came across this this article. What was it, last Friday, I guess, after the discussion we had. I thought I put it in there about the cluster sizing. Do I take few large clusters? Do I take many small clusters? Do I use namespaces in large clusters to segregate, and so on and so forth? So very interesting article. Obviously, it's more or less what I said. I wasn't completely wrong last week, but it's more or less what so few large clusters. Obviously, it's ease of management. You don't have tens of or hundreds of clusters to manage. Cost efficient, obviously. Optimal resource utilization, because you can really use them to the top. But you have single points of failure. Isolation is done through namespaces and other mechanisms, which might not be enough depending on the what do you call that, the regulations and stuff like that you might have. Management of non-namespaced resources can be complicated. I don't know if you remember last week we talked about namespaces and resources. And normally resources or Kubernetes objects, as you call it as well, they are bound to a namespace. So you create a deployment in a namespace, you create a service in a namespace, and so on and so forth. There are some resources or objects that are not namespaced, like persistent volumes, for example, that we've seen last week, or cluster role bindings and stuff like that. So that gets much more complicated if you have that in just a few large clusters and you have a lot of those. And obviously cluster size at the moment you get to a limit. I don't know what exactly the limit would be, but if you have hundreds or thousands of worker nodes, it can get quite hairy, and I guess you will get some network problems and stuff like that. On the other hand, for the many small clusters, obviously you have very strong isolation because the clusters are separated. So as I said last week, very often I see that customers are having dev test and stuff like that in a larger cluster, and then they have separate production or pre-production clusters, just to have this strong isolation that's done through separating the clusters. We have a reduced blast radius. Obviously, if a cluster goes down, that can happen. It shouldn't, but that can happen. It will take down only this one cluster and not your dev, your test, your prod, and everything that's running in one big hunking cluster. We have more granular access control, and the clusters can be customized. They can both be customized, but small clusters can really be customized for prod and for dev and so on and so forth. It's more costly. Why is that? Because for each and every cluster, you need at least 3 master nodes, if not more. So you will need VMs and resources to run those masters and to deduplicate it for each and every cluster that you're running. So that will take up more resources, and obviously it will be more complicated to manage the whole thing. Because if you have 100 clusters, someone has to monitor them separately and has to manage them. Inefficient resource usage. Obviously, if you have small clusters with smaller worker nodes, for example, it can be more inefficient to place your workloads. And we have, as I said, the operational overhead to handle all those clusters. So just to come back to that, because we had some discussion last week about that. So read this article. I just shamelessly copied that out of this article. I have to say that. That's why I put it in. So have a look at the article. It's much more complete than what I've been saying. It's very interesting read. And I've made an error last week, and I did one today with the wrong answer, but I'll correct that. So the Kubernetes demo app, some people had problems with starting it. So I've been talking about the resource, about the request and the limit. So the deployments, you can say, I request at least that much CPU cycle, CPU parts, so 150 thousandths of a CPU, so much memory, and then that's the limit. I cannot go over. So we've been discussing that in more detail last week. Won't go into detail, but I set them way too low. So I upped them now to 150 for the requests, and now it works. So on certain configs, they didn't come up because they didn't have enough CPU and memory, because there was a hard cut. And what happens in that case, and I talked about that last week also rapidly, is that Kubernetes just starts shooting those, just kills them. So so that was the problem. So they came up, couldn't correctly initialize, and then the probes that are checking if the whole thing is correctly running couldn't see it running, and they killed it. So if you have already run the welcome.sh before yesterday, please cd into the training directory. Just type git refresh. It's, by the way, for those who are interested, it's just it's an alias in the bash rc, and then go back to your home directory. Just do git refresh, and it will pull the new deployment that manifests. Okay. With that, questions? I don't see questions in the Slack other than that. Meeting passwords, yes, okay. So if there's no questions, let's jump into a short introduction to Kubernetes security. So before I go in there, Kubernetes security, and I hope Michael won't hit me over the head with what I'm saying in the next 2 hours. It's an extremely large and extremely vast, extremely complicated topic. So I'm really just touching on certain topics that I find interesting and that I come across pretty often in my work with my customers at IBM, and try to just shine a spotlight on them. So there's much more to it than I'll be able to show you today and in a week, but it will give you a good idea on the basics. Okay, so let's go back to our architecture. And I just added here what I call volumes, which would be the provisioner for the persistent volumes. Obviously, when your containers and your Kubernetes cluster starts saving persistent information into a rook ceph or into a cluster fs or into an NFS or whatever, this might be an attack vector. So the different attack vectors are first through the application. So obviously through the internet, through the applications that you have deployed in your Kubernetes cluster. If an application is unsafe by default and is exposed to the internet, you will have exactly the same security vulnerabilities that you had when you deployed them normally in a classical way, in a non-containerized way. One thing perhaps that helps mitigate that, if you remember last week, is the whole concept of services. So let's say I deploy a WordPress container and the MySQL container. So WordPress is accessing the MySQL container. If I don't create a service or anything, those will be completely invisible from the outside. So we don't have any attack surface by default on those. And what we will be doing is we will expose only the WordPress container or pod to the outside. So someone from the outside can contact and access the WordPress blog. Obviously, that's the goal of that. But we won't expose the MySQL database. So WordPress will be able to access the database internally with a cluster IP, so with a non-externally routable address, so 10.0. something, for example. So WordPress can access the database, but the database can by default not be accessed from the outside, so it's isolated. Now, obviously, I've been a developer for almost all my life, and then comes in the typical developer who says, okay, I have my MySQL tools on my Mac, and I want to do some data modifications in the MySQL database. Well, let's just expose it through a service. And that's when you increase, obviously, your attack surface. So really keep in mind to expose only the things that have to be visible from the outside. There's other mechanisms to access this database. Don't expose it. Okay, so that's one thing. I don't have that in my slides, just a little remark on the side. Okay, so the first one is through applications, can be either through the applications that are routed, that are exposed through services, ingresses, and so on, or directly onto the volumes. I won't be talking about this attack vector in detail. I mean, securing NFS shares and whatever is not part of this, but be aware that it's a possible attack vector. Second one, obviously, through the management and the API, directly to the API server, through the kubelet, or directly to the Docker instance that's running. So if you get access to the Docker instance, obviously you can start containers with malicious software that opens backdoors and stuff like that. And then last but not least is etcd. So etcd is this, it's the brain, if you want. It's the memory of the cluster. Everything's stored in there. We've seen that last week. So we store in here the desired state. So that's what we've seen last week. So that's what I have defined, what I want my my Kubernetes ecosystem, application ecosystem to look like. That's the manifest, that's the deployments, the services, and so on. They get stored in there. And we also store the state of the complete cluster in there. So imagine someone gets access to etcd. He's basically God in your cluster. He can do whatever he wants. It's even worse than if you have complete full administrative access to the API server, because you can do even more low-level stuff, because you don't have the checks that might be in place in the API server. So those are the three main attack vectors and the attack surface of your cluster. Now, it's not just something that we're talking about hypothetically. There have been attacks. I have a next slide with some more. One very interesting one was the billion lofts attack. Stupid name, but it basically allowed you to do a denial of service attack on your cluster by simply injecting a specifically prepared XML file. So what happens, there were some, I haven't read up exactly how it worked, but there were some nested and recursive references in this XML, and the API server didn't vet that. It didn't check for that. So the nesting references just grew and grew and grew, and they just killed completely or took over all the CPU and the RAM usage, and your server went down. Remember last week what I said? When your cluster starts running out of memory, it just starts more or less arbitrarily shooting and killing pods and running containers. And as I said, you can define critical objects that are growing at the very latest when there's really nothing else left. But your normal applications, they will get killed because it's starting to take over the whole cluster memory and cluster CPU. So that sounds stupid, but was extremely simple to do. Has been mitigated, by the way, in the meantime. But that was a real, let's say, attack use case, if you like. And then cool blog is aquasec.com. That's a firm who does some security stuff on Kubernetes. You can have a look at topic/security threats. There you have a long list. You can see we have 2 in here that are registered on CVE even. So, for example, a kube control path reversal, which allowed you to gain access to the host system. So that means that you can run a pod, and from this pod that's completely isolated, has no access to the host or to other pods, and in the end, if you do the right attack through this vulnerability, you get complete read and write access to the host system. So that gives you, again, your God basically on your cluster, so you can do whatever you like. And I just copied that out for this vulnerability here. For example, the CVE registration was on the 17th of April 2019, and the Git merge that corrected the problem was on the 30th. So it doesn't stay. Well, I haven't found when it has been released and what release of Kubernetes kube control it was, but it goes pretty fast. But still, you have often you have 2-3 weeks where the vulnerability is known and it's not patched. So it's not a myth. Attack vectors do exist, vulnerabilities do exist, and those are the ones that even work on more or less secured clusters. Now imagine if you don't secure your cluster. So now let's talk about how we can secure the hell out of our clusters. So the different attack surfaces. Let's talk about etcd. So obviously secure access to etcd. I think we'll be talking about it rapidly next week. Then the management API. So controlling access to the Kubernetes API. So who can access, what can they do, and so on. That will be next week. That's what we call RBAC, role-based access control. which is basically an absolute nightmare in Kubernetes. And I guess Michael can confirm that. It's one of the most complicated things that I've ever seen in my 35 plus years in IT. It's pretty complicated to handle that, but we go into detail next week, and there will be a lab to get you some hands-on for that. Access to the kubelet, obviously, that's what we've seen. If you can control the kubelet, you can start whatever you like on a worker node, including malicious workloads. Enforce resource usage limits. Again, that's to avoid stuff that well, it wouldn't have avoided the billion loss attack, but it will avoid that someone can start pods or containers deployments, whatever, that don't have any limits, so that can starve your cluster. So if you put limits in there, you can avoid most of it. Rotate infrastructure credentials, that goes with it, and then between the two of them, audit logging. I just have one slide. I won't be going into detail about logging, but so that you know who did what when, and you have a trace even for post-mortems if something goes wrong, that you know what's going on in your cluster. Then for the applications, SUSE Linux security features. I'll talk about that very rapidly. The privileges the containers run with, we talk about that. Network policies, that will be a bigger part of this presentation. That's one of the spotlights I want to do. Image scanning for your containers, so it's security scanning for vulnerabilities. We do that next week. And then the volume security, that would be, as I said, for securing NFSs and clusters and whatever that you might have that provide the persistent volumes. Questions? I haven't seen any questions in the Slack. Should I be frightened?
Maybe a question, or I hope everybody has now access to Slack. If not, please send again your email address. Most of you have already the invitation. You should have received an email and you should get access. Otherwise, still just send the email address here in the chat. Okay, so we're almost at the top of the hour already. I'm talking, and time flies. So I suggest that before going into the next module, we break for 5 minutes. What do you think? Let's shine this spotlight on some security elements in Kubernetes. So securing the workload. So let's talk about the network part first. So if you remember from last week, I presented you this modular construction of Kubernetes, which bases itself on the CRI, so the container runtime interface, the container storage, common storage interface, and common network interface. So here we're talking about the common network interface. So there are a lot of those under the sun. There's Calico, there's Open vSwitch. We're using Cilium in the Minikube environment in your VM. So you can plug basically in here whatever fits your needs. So they have all their different quirks, but help you basically set up software-defined networking for Kubernetes. And Kubernetes is completely oblivious to what you're using because it's going through this common network interface, which abstracts away what is underneath. So, for example, Calico, that's very popular, is one that operates at layer 3. So that's the network layer. So it can handle the really low-level protocols like TCP and so on and so forth. And it's based on IP tables, which is a native packet filter in the Linux kernel. So it's pretty secure. And it goes through the border gateway protocol. So like that, we can do cluster federation, stuff like that. So that's just one example. There are others. Cilium is, I think, on layer 6 or 7, so it's on the application layer. So it depends on what your goal is. I cannot go into detail in this episode, but just know that there's different ones that are here, and you need that to be able to define what we call network policies. So network policies is something that helps you
segregate further your pods that are running in the same cluster. So let's take, for example, an application with a web front end, with a database backend that's running in the production namespace, and then we have a pod that has been started in the default namespace. So I don't know, a developer has access to the default namespace. He can start up an Alpine pod or an Ubuntu pod or something, and then execute, get an execution shell into it. And what's nice about Kubernetes somewhat is that every pod can see each other pod. So there's no isolation whatsoever. So the guy that's in the pod number 1 in the default namespace could access theoretically the database pod that's running in production. So if he has the credentials, or if he can use a security vulnerability in the database engine or whatever, he could access the data, or corrupt the data, copy it out, or whatever. So that's not what we want. So we want to isolate that. So what we're doing is we're creating what we call a network policy. And again, you see the code as we've seen the last time as well. So we create a Kubernetes object of type network policy. Okay. And in here, we can define this one for the demo namespace. Sorry, that's an error because I changed it. It should be default namespace. I correct that before I send out the PDFs. And then in the specs, so in the specifications for this network policy, we say pod selector match labels, and we leave that empty. So nothing, it can access nothing outside. So this pod here in the default namespace, if we had default here in not demo namespace, cannot access any other pod. And we can even go further and do what we call the default deny all rule, where we don't specify the namespace and we say pod selector match labels, nothing. So no pod can talk to any other pod, which we don't want basically. But often we start with that. So we do a default deny all. So no one talks to no one. And then we start opening it up. That's the next one. So here what we say is, in my prod namespace, the ingress, all the traffic that's coming from a pod that matches the labels, so you can remember the labels. So we have the labels here, like DB backend, the web front end, stuff like that, where we say, all the traffic coming from web, so from the web container, can be received by the other pods in, by the pod that has the label DB. Okay, so we're opening a route or the routing between the web container and the DB container, but that's the only thing that will work in this cluster. So you can see network policies are pretty powerful means to isolate your workloads. And that's something, if you really want to have security and isolated namespaces and isolated pods and applications, please use network policies. But to use network policies, you need a CNI plugin, so Calico or Cilium or whatever. That's why I introduced it with that. Otherwise, network policy doesn't run. Okay, so that's basically what was to say about network policy. What's the difference between pod policy and network? Okay, network policy. Sorry, Yuri told me that I should read the question. So what is the difference between pod policy and network policy? So network policy is controlling how the pods can communicate between them. And the pod policy more or less defines what a pod is allowed to do, not on a network level, but on an access level. So accessing file systems and stuff like that. Okay. So network policy is really here to define who can talk to whom in your network. And what we would do afterwards here in this example is we will define a service and perhaps of type load balancer and an ingress, why not, or a route on OpenShift, on Red Hat OpenShift, to expose the web pod to the outside world. And like that, we really have the highest possible security. So I can access the web pod, so the web interface, from the outside. I cannot access the database from the outside because it's isolated, as I don't have a service on there. And the DB can only be accessed from the web pod. So maximum security here, maximum isolation. Next thing, on the containers level, here we can do a lot of mistakes. The first one, and I talked about that rapidly last week, is what we call the rolling tags. This famous column latest tag. Don't use that in production at least. If you use it in development, might be okay, but don't forget to change that when you go higher up in your delivery pipeline. So normally it's a good idea to implement that from the get-go, even in your development environment. So let's assume that we have the image registry. I have my latest image, which automatically gets the tag latest, and it is the version 2.1.1. So I deploy that to test, do my testing, everything works fine with the 2.1.1 version, and my deployment says what Docker run or the Kubernetes manifest web app latest. And now I deploy that into production, but in the meantime, someone has pushed a new version of the image into the registry. So if I use latest, it will use this image here, and that's untested because I tested the 2.1.1 version. So make sure that you tag that with 2.1.1 and not latest, like that you're sure that you have the right container. Probably in 99% of the cases, nothing happens, but one time is enough to get security problems or stability problems because you implemented some new interfaces or made some changes in the new pod. Okay, so very important. Avoid rolling tags. Next one, we talked about that last week. Don't run multiple processes per container. Well, and the week before. So a container normally runs one and only one process. And I gave you the example of SSH, for example, where I wanted to install SSH in addition to a web server into a pod to be able to SSH into it. As I said, you don't need that. You can use Docker execute or kube control execute or whatever, depending on where you're working. But one process per container like that, you keep your attack surface small, and you limit the number of potential vulnerabilities, because if you have a vulnerability in a process and put that process in another container, it might be in another container and it might be scanned and more easily discovered. So it keeps things segregated, it keeps things simple. So one process per container, and the same thing is true as well for what I said last week, one pod or one container per pod. Like that, again, you keep the attack surface small. Because you remember, if you deploy several containers, several containers in a pod, those containers have access to the same file system, to the PID and everything. So if the second container that you deploy has a security vulnerability, it might compromise the one that's running alongside in the same pod, and it does not. So like that, you have this, you reduce the blast radius again of an attack. Root user, by default, we rapidly talked about that 2 weeks ago. By default, a container, if you do your Docker file, runs as the root user, which may not be what you want. So what is good practice is to do either in the Docker file, change the user with the user directive. So you put user column and then another user, or do it at the latest in your deployment specifications in your manifests, and set the security context to run as user that has a high number UID. You can put in basically whatever you like. Be careful if you put in -1 or the floating point equivalent. I don't know, I don't remember what it is. It's like 4 million something or 40,000 something. I don't remember exactly. That translates back to -1. It will automatically get rounded to 0, and 0 is the root user again. So so go with something in the 10,000 range, and here should be good. Okay, well, let me perhaps just before we go further, the questions. I guess there will be no harm if I will have some other container for some pre-process work, like init container. Yes, that's something completely different, and I'm working, and I've said that already, I'm working on other installments of this training, a more Kubernetes advanced topic where I plan to talk about init containers. So I can just rapidly explain what that is for those who don't know that. If you run a container, let's say database, for example, with a persistent volume, obviously there's no data in there. And an init container, for example, is a container that you can define in your deployment YAML, in your deployment manifest, that will run before the main container is started. You can have several init containers, For example, an init container that waits that the persistent volume is provisioned. Then another one that that gets some data from somewhere else and pipes it into the database to initialize the data set in the database before starting up the main database engine, for example. So that would be init containers. And that's not a problem because they run in different pods. So an init container or an init pod is a separate pod that runs, so has its own PIDs, its own file space and everything. And once it's run afterwards, it's shut down, so it doesn't run anymore. So init container doesn't harm at all. That's the absolute best practice to initialize wherever needed a pod that's deployed. Second question was, is that recommended to deploy multiple containers in a pod? If there is a dependency. Yeah, well, okay. We talked about that last week. Normally you shouldn't. Let's go from there. Normally you should run just one container in a pod. There are exceptions with what we call the sidecar patterns, ambassador patterns, and so on and so forth, where you pack like a utility container on top of the other one, on top, besides the other one. A typical example, and we will see that in a second for Istio, for mesh networking, is that you pack a proxy into each pod that is started. So each deployment that you make, you will get automatically a proxy container that's deployed with it that handles the whole traffic. Like that, with that, we will see that in a second. You can do mesh networking and stuff like that. That's where it makes sense. That's where it's secure. You might also have a sidecar container, for example, or something else for log collection if needed. Usually log collection happens differently, but that's one possibility. But usually don't do that. And those containers, you say something like BusyBox. Yeah, it should be very lightweight, so that it doesn't take up much space, because it will be deployed with all the different deployments that we have. So you can do it, but start with the assumption that you should not have multiple containers in the pod. That's the rule, and then there's exceptions to the rule as often. Good. Privileged containers. Yes. As with Docker, you can do a Docker run -- privileged, for example. You can do the same thing in Kubernetes. And when you start a container or container in a pod as privileged, that gives it the ability to change stuff on the host, to access stuff on the host. So that can be extremely dangerous, because if you have access to the host, you have access to the PIDs, you have access to the whole process tree and everything. So you might start new processes and stuff like that. So privileged should be avoided. Platforms like Red Hat OpenShift, for example, by default don't allow privileged pods or containers to run. So that has been a little bit of a headache in the beginning, because there are some pods that have to run as privileged because they're collecting information from the host system, like dashboards and stuff like that, or logging things. So you can turn that off, but usually it's not a good idea. And over time, most existing solutions that you can run on Kubernetes don't require that anymore. We have learned to not do that anymore. So there might be exceptions, but the rule in itself is don't run them as privileged. Another one is the Linux capabilities. So if you run something in Docker, it has all the Linux capabilities. So like access to the NTP server, the time server, stuff like that. So usually they don't need that. So what you can do in your manifest, again, you can say security context capabilities drop all. So it has no capabilities whatsoever to the host system, and then you can add them if, for example, your pod has an absolute need to access the NTP server. You can do stuff like that. I won't go into details, but you can read up on that. There's a lot of very good articles on that. But that's one thing to keep in mind as well. And if you do all of that, it will become pretty much unlikely that someone can break out of a container. That's how we call it. And that's the dangerous thing. So if you start, I don't a container, and then you go in there. If it's privileged, has all the capabilities and so on and so forth, and it runs as root. There are ways to access the host system, to modify the host system, break out of this pod, of this isolation, and go to other pods and access other pods. Because remember the first install 2 weeks ago, when you're on the host system, you see all the processes from all your Docker containers, from all the pods, if you like, running on your host system. So if you do a Docker PS, for example, on your host, you see all the different pods, all different containers that are running, even if they're isolated and themselves cannot see each other. If you're on the host, you can see them all, you can access them all. So that's the breakout. So to avoid breakout, if you respect that, you're already pretty much advanced. Some tooling. There's hundreds of tools under the sun. I tried to get the best known and the ones that I'm using as well. The first one is conftest. That's a utility basically that where you can write tests against structured configuration data. So it works against Kubernetes configuration, against Docker files, Tekton pipelines, Terraform serverless, whatever. As long as it's structured data, you can write rules or policies, as they call it, and check the source files, so the manifests themselves before deploying them, if there's stuff in there that should not be in there or that should be corrected. Okay, so you see an example here. I did a conf test, and you will be doing that in the labs, by the way. And that's one of the tools that's pre-installed. You give it the policies that you want, so that's a directory with several policies in there, and I apply that to the famous demo app, the Kubernetes demo app that we've already used last week. Scans it, and you get back some elements. For example, a container that runs at root, the Kubernetes demo. I didn't put in the user change in here. Must provide app release, okay. Must include Kubernetes recommended labels, okay. I didn't do that. And found deployment, but deployments are not allowed, okay. And you see, I have 1 of 5 who passed, and then you can act on that, and you can get the same thing if you say output JSON, for example. You can get it in JSON format. So so you will be able to integrate that in a continuous delivery pipe or continuous integration pipeline before deploying. Scan your stuff, and then act and say, okay, I can deploy or I cannot deploy. Okay. Second one here was a test on a Docker file that we did for the examples. And here it finds, for example, that there's an image in there that I'm not allowed to use because it has vulnerabilities in there. Okay, so that's the first one, conf test. Pretty easy to implement. Command line gives you back JSON or text, and you can act on that then to take decisions and say if you want to deploy or not. Typically, for example, in a Jenkins pipeline, you could integrate that. Another one is Polaris. That's not command line. That's a Kubernetes deployment that gives you a web interface afterwards, that scans all the different elements in your cluster and gives you recommendations afterwards. For example, for this one here, for a daemon set here, host PID should not be configured, blah, blah, blah. Here we have the requests and the limits that are not set. So we talked about that some minutes ago about resource starvation. So you should set that. Then readiness and liveness probes. That's not something I'm going to talk about today, neither in this six courses, but that's something that would come in the advanced one. If I can get it to live in time, we might add a seventh episode to the 6th that we already have, and so on and so forth. Should not be allowed to run. That's basically, if you like, a more graphical view of conf test. It's not exactly the same, but it gives you very similar information. So that's something that's more visual, and you will do that also in the labs. Okay, next one. Let's talk about securing management and API and keywords and stuff like that. So use namespaces liberally. Someone, I don't remember who was it, said namespaces are cheap. They don't cost anything. Now, why would you use namespaces? Well, one, to structure your different elements and to segregate them, because you can do the network policies by namespace, so you can use them to segregate your network, who can talk to who, okay? So you can, for example, say you can define a network policy, say, okay, everything in my prod namespace can talk to each other, but nothing outside can enter, has an ingress into this namespace, okay? And then we have this famous RBAC we're going to talk about next week, where I can secure and limit the access to resources that are in a specific namespace. So I can secure it on a network level, and I can secure it on an access level. We'll be talking about that next week. So use namespaces, use them extensively. They don't cost anything. They give you the means to logically segregate so that you know where to find your stuff, and then to secure from an access point of view and secure from a network point of view. Okay. Now, for some more tooling, very nice one is kubesec, which does security risk analysis on resources. Okay, so here again, it will give you a list of what is okay, what's not okay, and you get a score, and that's pretty nifty, because this score, you can act on that. So that's even easier to scan your deployments and whatnot, and then react to the score and say, okay, if I'm above such and such score, I block the deployment, that I don't go further, and I send a message or an alert to the developer or whatever. Okay, so that's kubesec. You will be doing that as well. Another one, a kube hunter, and here I put it in red. I call that black box scan. It's not exactly black box scan, but it does scan your clusters for vulnerabilities, for open stuff, for misconfigured kubelets, and so on and so forth. So please run this thing only on the clusters that you own, okay? Because if you run that on other clusters, it might be seen as an attack, okay? You will be doing that as well on the Minikube installation to see if there's some problems in there, if kubelet is misconfigured and stuff like that. Okay, so I have a question: is this kubesec a CLI tool? Yes, everything's CLI tools except Polaris, and that makes it really nice, because you can integrate them pretty easily into CI/CD pipeline. But Kube Hunter is not an executable if you want. It's a Python script, but in the end it's command line. Good, and the last one, and I added that recently, is Falco, which is an incubating CNCF project now. It's been donated by Sysdig, who normally know exactly what they're doing. They're pretty good at that, and they go a little bit in another route. They parse the Linux system calls from the kernel at runtime. So it looks at what are the system calls on the kernel level. And then we have a rules engine that will flag anything that happens in the kernel and related to Kubernetes that should not be happening. And then it posts it to NATS, and then you can do stuff with it. So it's some sort of queuing mechanism. For example, you could kill an offending pod if a pod is starting to try to access some resources that it shouldn't and stuff like that. Then you could, for example, kill the pod directly. So I'm not very familiar with that, and it's not in the labs yet, but if you want, you can have a look at that. It looks pretty promising, and as it has been accepted into CNCF, it will probably go much further than what it is today. Good. No other questions in the meantime. Let me look. Okay, no other questions. So let's talk about mesh networking. That's a way also to secure and better control network access to your different elements of your application, so pods. So a service mesh basically is an infrastructure layer that makes service-to-service communication. So service-to-service here would be pod-to-pod, if you want, faster, safer, and more reliable. Now, how does this work? And I won't go into detail because we have in 2 weeks, we have a dedicated Istio course. No, in 3 weeks, the last one will be on Istio. So what happens is that I have my pods. Okay, so I have a service A and a service B. The pod is running a container pod service A, and the other one is service B. So afterwards, I define what we call a mesh boundary, and the mesh boundary will have an ingress and an egress statement. So traffic coming in, traffic going out. So basically, it's a proxy. In this case, it's what is it called? The proxy traffic. I don't remember. I have to look it up. So those are proxies, like you have the standard proxy that you have in your Kubernetes cluster. It's an additional proxy that gets deployed along the lines of Nginx or HA proxy. And thank you, Ramesh. It's Envoy. I forgot that. A project that has been donated by Lyft, by the way, the other guys from the Ubers. So you have those ingresses and egresses in the mesh boundary. So you define a boundary where your applications live, okay, your pods, and then you have one way in and one way out. And now what happens is each time you deploy a new pod, so you make a deployment or whatever, we automatically get an Envoy proxy as a sidecar or ambassador pattern, to be more precise, in each pod that you deploy. Okay, so I deploy a new pod. This proxy gets added to the pod for each pod. Okay, so it will only work for the new pods. The existing ones, it won't attach them after the fact. So you will have to delete and recreate the whole thing. And as we'll see in 3 weeks, you can specify that by namespace as well. You can say, I only want to do that, for example, for my namespace prod and namespace test, and not for the dev. Okay, so I have pretty good control over where this proxy gets added. Now, what does this proxy do? So let me go a little bit further. Oh, okay. So I have a control plane, and we will see in detail in 3 weeks what it looks like, what it does. But this control plane basically can define how these proxies react. So it can tell, for example, this proxy that all the traffic that's coming in, going to this URL with these properties, can be routed to the container service A. Okay. Same for service B, and so on. And this control plane will do authentication, can do authorization, can do routing, can do load balancing, and whatever. So it's really extremely powerful. And you have to imagine the traffic is coming in the ingress, and it's flowing like a mesh through all the pods, through all the proxies. And the proxies say, hey, yes, this traffic is for me, grabs it and routes it to the payload, if you like, which will be service A and service B. But just very rapidly, what can you do with that? You can do traffic control, canary testing, and A/B testing. So that's stuff where you can say, okay, I have a version 1 and the version 2 of my pod. And then you can say, okay, now I want to start, and you can deploy version 2. You already have version 1. And then you can say, okay, now I want to start routing 5% of all the traffic to my version 2. And then you see how it goes. And then you route, if everything's okay, you route 25% to the set to V2. And then you route 50% and so on. So you can do gradual rollouts of new deployments. And if your support lines don't blow up, there's a good chance that you can go on and roll out to 100%. And if there's a problem, you can do a rollback directly to the version 1 just by modifying the weights of the distribution. So you don't have to redeploy anything or whatever. You just adapt the routing properties. So that's extremely powerful. Okay, so that's canary testing. So it's like holding the toe in the water and see if the thing flies. Afterwards, we can do stuff as well. For example, say if someone comes in and is logged in as a tester, route him to the V2, but all the others still go to the V1. So like that, you can have test traffic going to another one, to the new one, but not the old one, without having to change the routing of your load balancer or whatever. So it's really powerful. So we go into details on the rest in 3 weeks. Okay. Good. I have some questions. Hello, Nick. How do we get the change you made to the Kubernetes lab to correct the mistake? Okay. Yes, perfect. Thank you, Ramesh. You got your answer. That's good. I don't even have to take it. So yeah, just go into don't go into the training standalone. Just go into training, because the Git repository is training, and then you run git refresh. So like that, it refreshes the whole structure. Okay. And then go back to the home. Okay. Let's talk about network encryption. That's again external. So certificate management for TLS can be pretty harsh, pretty complicated to handle that. And there's a project called Cert Manager, open source, that will help you for issuing and renewing and so on and handling your certificates. So this Cert Manager can grab signed certificates from Let's Encrypt, from HashiCorp Vault, Benefit, whatever, okay? Or you can do it yourself signs if you like, but normally the problem with self signs is that you get errors and whatever, and you have to say, yeah, I'm sure what I'm doing. I sell you my firstborn and whatever. Okay, so Cert Manager is pretty nifty, and how it works is when I have my pod here, that's my application app one. I have my ingress pod, which in this case would be Nginx. For OpenShift, it would be HA proxy. It might be something else. Doesn't matter. I have my ingress pod. So I'm calling the ingress through HTTPS, so through port 443. Okay. So normally I get a preloaded self-signed certificate, and my Firefox browser will tell me that that's not secure and whatever. And then the traffic will be routed to the pod. Okay, perhaps why not on port 3000 for a Node.js application. Now in the same cluster, I can install Cert Manager. And what Cert Manager does, and we see that in detail afterwards, is it does an ACME challenge. And ACME, I have to look it up, stands for Automated Certificate Management Environment. Okay, so it calls out to Let's Encrypt, for example, that's the basic use case, and gets a signed certificate, a valid certificate from Let's Encrypt, and creates and stores that in a secret. Let's call it my secret. Okay, so you have a valid TLS secret in my secret. And then Nginx will use this secret to terminate the TLS or the HTTPS traffic, and then internally route it to the ingress that routes to that. Okay, so here you get a completely signed, perfect certificate. Now, from the code perspective, how does that look? So first, we have the pod. I didn't put in the code for the pod. That would be deployment, called app1. We create the service. Let's call it app1 as well, and that's the selector app1 for the front end here, for example. Doesn't matter. So this service will be bound to my pod. Okay, up here, nothing new under the sun. Now I want create a certificate. So here I will create something called a cluster issuer, an object of type cluster issuer. Let's call it let's encrypt staging. That's free. And then you specify ACME for the protocol, the server, then your email address, and so on and so forth, and the secret where you want to store it. Now here, just one little information. You see here I have ACME staging. ACME staging gives you certificates for testing. Those are not production-ready certificates. But if you want to test a thing, if you put, I think it's production here, or prod or something, actually prod, I don't remember the exact URL. If you go to prod, you are rate limited. So you can only ask for, I don't know how many certificates a day or for a certain amount of time. So if you start testing against the prod API of Let's Encrypt, very rapidly it will tell you, no, you're out of quota, so please come back later. So for testing, use the staging URL. So this will create the cluster issuer, and then I create my ingress. The ingress links to the service name app1 that we had. Well, let me put it here. That we have here, service app1. So we have app1, and we make an annotation, Cert Manager cluster issuer, and we give it the name of the cluster issuer. Like that, it knows where it has to go to create the certificate, to issue the certificate if needed. And we specify here the TLS. So we say, okay, we want the TLS termination, and the secret, the TLS certificate is my secret, would be the one that's created by the customer, the cluster issuer. Okay. Now, the host here, appexample.com, and here you would have to add it also. I didn't do, but you have to give it a host that is accessible from Let's Encrypt themselves. So it has to be routable from the internet. Okay, that's why I couldn't do. I tried to do a lab for that with forwarding and whatnot, but it doesn't work because our local Minikube that's running in a VM that's running on your machine behind the firewall probably. There's no way we can get this certificate issued. So that's why it's not in the labs. I tried very hard to do it. I couldn't find a way to do it. Perhaps I'll find one in the future. Okay. So there's questions. What is annotation in this context? I get into that. How long will it take for the environment to reach running state? Okay. Well, it can take a while. It can take 5 to 10 minutes, depending on below screen. I can see the screen yet, but it can take some time because it has to pull several images from the intranets. So an annotation is something that gets usually or very often gets created automatically. For example, if you look at the persistent volume that has been created through a dynamic provision, so you create your PVC, so your persistent volume claim, and if it's capable, if the storage class is capable of creating the PV, the persistent volume automatically, it will create it, and it will create a lot of annotations to say, okay, it has been created by this one and does that, and so on and so forth. But annotations can also be used to be consumed by stuff like this cert manager, for example. Okay, so cert manager will look at those annotations in the ingress, and it knows what it has to do. That it has to use this cluster issuer to create the secret if it hasn't been done. But I'm not the big pro about annotations. I use them when you have to use them, but I've never gone further than that. Okay. Okay, how different is doing this network encryption from using web server SSL? Well, it is an SSL termination. So the thing is that it's probably not a good idea to do TLS termination directly in the pod, because you want your TLS termination on the ingress level where you get into the cluster, so that you have one IP, one URL with one IP address of the cluster, and that everything TLS termination gets handled at the cluster boundaries in this ingress Nginx or HA proxy or whatever it is. Okay, that's the idea. You could do, I think, if I'm not completely mistaken, you could do TLS or HTTP or SSL termination, whatever you want to call it, directly in the pod that runs a web server. That's possible, but in which case you have to wave the traffic through completely to the pod, and the termination is done there. It's probably a bit less flexible, but you could do that. Okay, did you send me the screen? Still waiting. Yeah, I mean, as long as it's saying still waiting for personal training environment to reach running state, I think you should be waiting, because it's still pulling the image. Try running K9s, the tool, and check on the status. You know what? Let me just go rapidly back. So I'm slide 67, just to remember. And just let me pull off. Where is it? Here. This one. So if you launch K9s, you will get something that looks like that. Hopefully without any red. But if your student UI, that's the personal training environment that runs in the default namespace, is still on the container creating, what you can do is hit D for describe, and then scroll all the way down, and then you should see a container pooling or something. So there you have at the end, if you do D, describe, and go all to the end, you have all the events that happened in your pod. and the last one will probably be container pooling, or I don't remember what the exact term is, but something along the lines. And there you know that that your image is still pulling, and that you just have to wait. If there's something else, ping me, okay? Muhammad, any K9s cheat available? I'm starting to laugh. Yeah, I frankly, I've been in love, and I cannot stress it enough. It's my absolute go-to tool. I use it a little bit less because I'm working a lot with OpenShift, obviously, because IBM has acquired Red Hat, so we're full OpenShift now, and their web interface is really, really good. So I'm starting to do half-half. K9s is just really simple, really rapid to check something and do some modifications. If I have to do some little more complicated stuff, I go into the web interface. And I don't have a cheat sheet per se, but you can do, no, you cannot see it on the screenshot. When you run K9s and you make it really big, I think it is just question mark, if I'm not mistaken, or something, and you get all the common reference. Just try. I might have a look just afterwards to check it out. Okay. And otherwise, just go to the Git repository of K9s, and you get a little introduction. They enormously extended it now, by the way, and you can use your own color coding so that, for example, red is not red but blue and stuff like that. You can add plugins and stuff. There's a lot of stuff for customization now that you can do in K9s if needed. Okay, good. Just one slide about logging. Unfortunately, we don't have time in this short 2 hours to go into detail. Logging is pretty important, as one side to know what's going on in your cluster, and on the other side to know who's using your cluster and what comes in goes out. Very often we have what we call an ELK stack, ELK, which stands for Elasticsearch, Logstash, Kibana. So Elasticsearch is this open source full text search engine. Logstash is a tool that collects and parses, stores the logs, and Kibana is on top. Is the one that shows you visualizes the whole thing. So that's pretty nifty and pretty standard. So EF key, it's Elasticsearch Fluent D, which is not on the list here, Kibana, which is used on OpenShift, for example, pretty much the same. But that's basically how you do it. So you get all the logs in Logstash, get collected, get it in. Elasticsearch is the search engine on top that aggregates and does the full text search, and Kibana is for visualizing the whole thing. So the good thing with that is, I don't know, I didn't talk about that last week, but one thing where you start banging your head against the wall, for example, if you have a deployment and your pod is in the worst state that you can have, which is a crash loop back off. I don't know if you've seen that when you did your deployments. When it's not running or container creating or whatever, but when it says crash loop back off, that just means that the workload, the container has crashed and it doesn't come up after a certain amount of time, it doesn't come up. And then you have to go in and start debugging the thing. And if you go into the log of the pod, this log exists for the time that the pod exists, okay? So what happens now is that the pod comes up, it cannot start. After a while, it gets killed and the pod is gone. So you don't have access to the logs anymore. And in the logging environment, you have that because it's collecting the whole stuff. You would go to your logging component, your logging system, and there you can see what happened before, even if the pod is not existing anymore. Fluent D is different from Fighting. Frank, I couldn't tell you, sorry, what's the difference. I'm not that of a pro. I'm more of a user of this stack. I'm not a big pro on that. I don't know what the difference is. The only thing is that I can tell you the difference between EFK and ELK stack. I couldn't see any notable differences, frankly. I guess Heapster is no more with Kubernetes new versions than we have metric server that we need to add manually from our side. Yes, I think Heapster is being phased out now. Yeah, there's some stuff happening. This slide has a certain age as well. I didn't update it, And I didn't want to go into detail, but that's something that that I might be talking in another time. Okay. Okay, let's go on. Questions. I guess I answered them more or less. Let me just pause for 30 seconds. So if you have questions, type them now into Slack. Yurid, are there any questions in the chat that I cannot see?
No, I
No?
don't
Okay.
think so. They were posted in Slack.
Okay, very good. So let me take you that's a pretty quick one through the DevSecOps part, and we should be able to break around 1600, 4 p.m. and then we can have the last hour for the labs. Okay, DevSecOps. I've been talking rapidly last week about DevOps, the whole DevOps and automation, and how we would do that in a more cloud native way. And DevOps, well, you can say it's about bringing operations and development together. Yeah, well, that's probably a bit easy, but I mean, I've been doing a lot of DevOps with my customer, DevOps consulting and stuff like that. It's much more than that, but let's leave it at that. And DevSecOps is just to bring them together with security functions. So build security in. And again, down here, there's a very nice article, Insecure by Default. I love this one. I discovered that just last week after the training. And the guy is pretty right. If you look at all the CI/CD pipeline workflows, Kubernetes oriented ones that you find on the web, and he has a very nice diagram in his article where it just shows the Google search with images, and on almost literally none of them find security related stuff. Well, we have run tests, but usually here we're talking about functional tests, unit tests and stuff like that. So let's have a look again, just a little reminder what normal standard CI/CD pipeline with GitOps, so with Git related, Git oriented DevOps might be. So the mother of everything is the application sources that you have in your Git. So a developer checks in code. And again, as I said last week, it's probably not a check-in because the developer will have its own branch, but we won't be talking about that. Otherwise, we're here until 9 o'clock p.m. So let's say it's a merge. So something goes into the master branch that has to be deployed. Okay, the other stuff we'll leave it out for 10 days. What happens is I have my continuous integration process. It might be Jenkins or something else that will take this code, either fetch it if you manually, or you have a webhook that kicks it off automatically. Then you have your Mavens and Gradles and NPMs and whatever in this world that might build your application package. And then you can run your unit tests on that, and you're good. You have your package. Then the second part of the CI pipeline, again, might be Jenkins or something more Kubernetes native like Tekton, for example. You build your image from this package because this might be a WAR file or might be something else. Now, the build part here is more and more often done in the build image. So, for example, if you have a Golang application or a Node.js application, hell, even for Maven builds, sometimes you use the Docker build directly. So you will have a first image that runs a Maven base image that just takes the sources, creates the package here, and then we have a second stage Docker file that creates the application, so the container, the image out of the what has been compiled. And that's what we call, and I referenced that rapidly 2 weeks ago, I guess, is this multi-stage builds, multi-stage Docker builds. And that's one of the best practices that's coming out. And for an example, the Kubernetes demo app that you've been using and that you will be using today does the building of the whole thing. It's based on Node.js. So it just pulls in the sources with the dependencies, and then it launches an npm install, which pulls in all the dependencies and other sub-projects, which basically is the build in the Node.js environment, and then it builds the image out of that. So it depends. It might slightly vary, but I wanted to separate it to really clearly show that we build something, get a package, can do some unit testing, build an image, and then we push the image into the registry. Afterwards, we update our Kubernetes deployment manifests. Okay, so those manifests are the deployment YAMLs, are the service YAMLs, and so on and so forth. Obviously, you have to update them, for example, just to put in the new tag for the new image that you just built. Okay, so if you have the Kubernetes demo app column 1.0, if you build the 2.0, you have to update that in your Kubernetes deployment, and that goes usually in a really streamlined GitOps process, goes in a separate Git repository that we call the manifest repository. Okay, I'm coming back to that in a second. And then we're able to deploy it. Now, we can kick off the deployment automatically, or we can do it manually. Again, we can use Jenkins, Tekton, or IBM Urban Code, or whatever. There are thousand tools under the sun here. So we want to deploy this to dev, to be able to do smoke testing. So the process will pull the manifests, will create the objects. So my deployments, my replica sets, my pods, my services, whatever. And the clustered deployments will pull the images from the registry that I just pushed before. Then we can do some smoke testing, for example, and then it goes through the process, deploys into test, does some integration testing, deploys into prod, and so on. So this is very schematic. Not usually probably you will have a user acceptance test or pre-prod or whatever you might call it here. It's really just for the example. Now, what I also rapidly talked about is this segregation of application sources, the Kubernetes manifest, and then we have our platform. Very often today we're talking about 3 different roles now in GitOps. Okay, the first one is the application developer. So this one produces the source code. So he's responsible for creating the source code, for coding the application. Then we have the application operator, as we call that, okay, which is responsible for the manifest. So how do I deploy, how do I operationalize, can you say that? It's terrible. My application, how do I put it onto my infrastructure? And then you have the infrastructure operators, classic, that takes care of the Kubernetes cluster and the underlying VMs and everything, okay? So very often now we can see 3 different roles. So application developer, application operator, and infrastructure operator. That's why you do it like that. Now, obviously on here, we don't have any security tests. Now, where do those things go? So let's move that a little bit down. So the first one is at the unit test level. What's in gray is something that we didn't cover and we won't cover. So here you have the Sonar cubes, which is more or less the standard today, or others, where you can check your unit test coverage, the complexity of your code and whatever. Okay, you have your dashboards. You can say, okay, my code has a certain level of quality, so I'm okay with going further in my process. Okay, so that's the first stage. And by the way, unit test is always a little bit of a problem, because developers, again, I've been a developer for almost all my life. We hate writing unit tests. So you need unit tests here, and that's a very important thing, but it's easier to be said than done. Okay, so that's the first thing at this level. Then when we update our Kubernetes deployments, please check them before checking them into the Git repository. You have kubesec, you have conftest. Well, Polaris is not command line, but you could use it to scan them rapidly. So pipe them through there. So before they go into the Git repository and would be ready to be pushed out to the clusters, they get vetted and controlled so that you don't publish or update or deploy something that doesn't meet your quality standard. That's exactly here where you can act on those quality levels, this rating that comes back and say, okay, if I'm below 10 rate or if I'm above 5 rating or whatever, I block it and I don't push it into the manifest, and it goes back to the guys. Okay, so that's the application operator's responsibility, and he should be the one who gets a notification if those fail. Then another thing, when I built the image, and it's in red because we will doing that next week, is image scanning. So when I build my image, before I push it into the registry, scan it. And there's freeware open source projects like Claire, for example, which is becoming one of the standards. And again, it's also part of Red Hat OpenShift, for example. It's used in there in the Quay registry. This is something that takes your image, goes through it, looks how it has been constructed. If there's elements in there that have known vulnerabilities, for example, is there do you add some SSH stuff in there, or do you add a web server that has known vulnerabilities, and so on and so forth. And here again, so you would build your image, scan your image. If your image has a certain profile of vulnerabilities, don't push it and just break here. Don't push and don't update here. If that's okay, go to the deployment files, check them with kubesec, conftest, and so on and so forth. And if that is right, deploy it into the Kubernetes manifest Git repository. Like that, you're sure that everything, well, you're pretty sure as sure can be, that you've done whatever is possible to mitigate the risks in the CI part of it. Now let's go to the CD part, and here's something missing up here. So when you start your CD, make sure that you do the same thing that you do down here. If you get your manifests in here, just run the validation again. Kubesec conftest. You never know. Perhaps someone did something manually or did some stupid things that went around the mechanism here, the control mechanism. So just check it again, just to be 100% sure. You check it when it goes out, and you recheck it when it comes in, just to make 100% sure. Okay. And then we go through that, and then, well, smoke tests, typically would do that with kubectl or curl, check if a web page is responding and whatever. There's a lot of different possibilities here. Then integration tests, integration tests and or, it's functional, non-functional tests, I should name it that. You can use Selenium, JMeter, and so a Locust and stuff like that to do your more functional testing afterwards. And then we have KubeHunter, Falco, and so on and so forth that are acting directly on the running cluster. So those are examining your clusters that are running and are highlighting, if you want, or finding problems that you might have with the running cluster. And those here would go to the infrastructure operators afterwards if there's a problem with that. Okay. So that's basically that for the CI/CD pipeline. So you can see you have a lot of ways to do security checks, and there's much more that you can do. But that would be, if I had to implement that at the customer side, that would be more or less what I would put into place for a start, to be sure that they have a more or less clear governance, security governance model in such a pipeline. Okay. Well, sorry. There's a question. The dedicated dev cluster is defined in the manifest. Who manages that? Okay. No, it's not. No, not in my, at least not in my example. I'm starting from the idea that those are existing already. I have a dev cluster, I have a test cluster, and I have a prod cluster that are managed by the infrastructure operator, and they are already existing. Now, as you can see, and that's a very good question, and I'm overshooting slightly the 4 p.m. Sorry, but I try to wrap that up before we break. We have a repository with the application source, so we have full accountability for who has done what, when, what are the changes. The same thing for the manifests. So we know who has changed the manifest. Everything's versioned. Everything can be audited. On this side here, we could do the same. We could have a Git repository for our infrastructure as a code. So we could use Ansible, we could use Chef, we could use Terraform, and so on and so forth to stand up our clusters. And that would be, if we go farther, it's not part of the CI/CD pipeline, but if we go farther, that would be what I would add at the very end to say, okay, we have everything on the version control, everything's auditable from code to deployment manifests. Now let's do the same thing for our infrastructure. So let's define my clusters in Terraform, for example, configure them with Ansible, and store everything as well in a Git repository, or in a versioned way at least. Like that, we have the infrastructure operators who will be responsible for that code, and we have full accountability again. Hope that answers that. Okay, just the last one. We didn't see that yet because it comes in the next installment. But just so that you know, in Kubernetes, when you call, or let's say you create a deployment, okay? So you do kube control, create -f my deployment.yaml. There's a certain number of different steps that you go through before the whole thing is committed to etcd, because that's what happens. At the end, it's committed to etcd, and you remember we have the controls and the schedulers that are picking it up, that are writing back the state into etcd, and at the end, the kubelet is picking it up and is deploying whatever has to be deployed. So we have different steps, and we go into detail next week. But first we have authentication, then we have authorization. So that's who am I? Can I? Then we have what we call mutating admission, and there's something missing. We call it like that, but the full name would be mutating admission webhook. Okay, there's a webhook at the end. So here you can say that's typically where the Istio magic is happening. So here, when you create something, there's a webhook. It's like small plugins, if you like, that are here. So let's say something comes in that might require a sidecar. So there's Istio admission, mutating admission webhook. Says, okay, that looks like I have to add a sidecar. So it will take the YAML file that you sent to the cluster and adds the code for the envoy, for the proxy sidecar automatically. So that happens here. Then it validates the schema of the whole thing once it has been altered. So to be sure that we have valid YAML. And then at the end, we have what we call the validating admission webhook. So that's the last bastion before anything gets written into etcd, and the last moment where we can reject a create or delete or something that comes from the API. And in this validation webhook, oh hell, it comes at the very end. You could insert, for example, an image scanning, like with Claire again. That will slow down the deployment, obviously, because it won't be committed. Nothing will happen until the image scan has happened. But you might be able to say, okay, every time I want to deploy something, this validating admission webhook checks if the image has vulnerabilities or not. And if it doesn't, then we can commit it to etcd. Okay? Normally, you probably wouldn't put an image scanner in here because it's too slow. But there's other ways. There's a project called Notary that you might have a look at. Again, I won't be talking about that because it's just don't have enough time, which helps you like notarize images that you have built. So you could just check with Notary here, for example, say, okay, I have this and that image that I want to deploy. It has this fingerprint, this hash. Has this hash been validated and vetted before? If so, go through. If not, don't do it. So that's a superb way of securing everything that comes into your cluster. So short of accessing etcd directly, if it's not secured, you cannot publish anything. You cannot circumvent this validating admission webhook if you have something in there. So that's a pretty powerful gatekeeper, if you like, for security. Questions? Well, the last questions was clear, I guess. That was the definition. Otherwise, we break 5 minutes. We start at the 1/4 with the hands-on. I have 2 or 3 things to say, and then you can go into the labs. And Yuri and I will stay around until 5 p.m. If you have questions. Okay? So let's break for 5 minutes and be back at 5 past. So there was a question which one we should be doing. It's JTC 16. So you click on the drop-down, begin course. And there's 2 labs, pretty short. One is about network policies, and then a first part security tooling. the next ones will be next week on next Wednesday. I have some reading tips for Kubernetes security, so you can click on them. I will publish the slides either later today or tomorrow, depends on my email inbox. I have to look at that afterwards, but you will get everything. Some reading tips, we've already done that: cloud adoption playbook, Kubernetes in enterprise, more for Kubernetes, and cloud adoption, and then Kubernetes security, which is a must to read if you're into Kubernetes. It's a very good reference, and I pulled a lot of information out of there. Okay, so again, sources are here. You have that. Before jumping off, see you next week, same place, same time. So next Wednesday, 2 o'clock Central European time. We will have a preparation Q&A on Tuesday, as always, at the 5:15. To roughly, normally it's to 6:15, but normally we shorten it if we don't see any new arrivals. So it will be probably around 5:45 or something like that. Okay. So with that, so it's Kubernetes Security Advanced next week, where we go a little bit more into detail on RBAC